Hello everyone, we are going to continue today with intermediate algorithms, starting with the largest number in an array. So we have an array. This array contains four elements, for example, and all of these elements are arrays. What I want to do, I want to return the largest number in each of these sub-arrays. Okay, and for today we are going to do all algorithms in functions, so we will do this algorithm in a function. Starting with a piece of the code, I want to declare, or let's say define, a function. This function will take an array as a parameter. Okay, why does it take an array, not four arrays? Because these four arrays are subarrays inside the parent array. So I will pass the whole array for this function. Okay, good. Now I have a function. Takes the array as a parameter. No, I want to define a variable. Yeah, variable, which is an empty array. Why I defined an empty array? So I will put each of the largest numbers inside this variable. So at the end, I have an array contains four elements or four numbers. Each of this number is the largest of each is the largest number of each of these subarrays. Okay, we have a function. Now we have a variable. I want two for loops. Why two for loops? We will see. For loop, iterate through the array itself and for loop to iterate through each subarray, not some sub. Yeah. Okay. Now I want to condition. Yeah, if condition. Okay. To compare the variable, which is the element of the given array or the empty array, where I will add an element inside it. We will see that next. So I want a condition to compare the value. Let's say yeah, the value of two variables. I want the variable in the array and a each element in the array. Okay, so we will say if condition to compare the value of the uh, uh, or let's say if condition to check which number is bigger or larger, yeah, bigger. And then I want to uh, let's yeah, if true, I'm going to push in the empty array. And I want to return the new array I made or the empty array, but when I return it, it's not going to be empty. Let's start with the code. I want a function. Yeah, a function. Let's call it largest number in array. Uh, largest number. Yeah. This function will take an array as a parameter, and then I will define. No, I will define an empty array. Let's call it x, for example. And now I want a for loop to iterate through. It's a big array or the parent array. I is less than ar dot length exactly I plus plus. And now before going to the next for loop, I want to do something. I'm going to say x dot push, or you can say no, I prefer x dot push because is an empty. Yeah, it's empty. Yeah, so let's say x dot push. What I'm going to push, I'm going to push array I 0. What does that mean? Array I, for example, when I 0, so array 0 is this one, and the next 0 to refer to the first element of this array. Why did I do that? You can simply start with 0, make this array, you can say push 0, and it work, but if we have an array of negative numbers, it's not going to work. I think I did something similar in algorithms before. You can check to get the reason why I do this. So I want another for loop to iterate through all the subarrays. It's x, sorry, not x, ar I dot F, yeah, and J plus plus, exactly. So now I want the condition to check if X I is less than AR I J, then make X equal to, make XI, yes, equal to AR I J. So ARI, it's the first array or first subarray, and J is the element inside of these subarrays. Okay, so now we did this, and here after this for loop, I will say push wait, x dot push, yeah. Okay. Wait, I think there's no need for x dot push. Yeah, no need for x push. Okay, after the last for loop, I want to return x. Exactly. So now let's check largest num, and I will use this array here. Control C, and if I say let array equal to the following, I want to apply the function on array, and let's run. Here it is. I get the largest number in each of these subarrays. Now let's go to the T diagram. Okay, I want to see both the grains together. I want to delete this. Okay, so we'll start with index I. Also, I have index j. Then the condition and the result. What changes have made? I equal to 0. When I equal to 0, I want to write something here. So I'm working with the array. I want to add a field here just for more explanation. I write here index j, then the condition and the result. So when I equal to 0, AR0, it's the whole array, the whole subarray, which is 4, 5, 1003. And x now, sorry, yeah, x now contain one element which I already pushed with the syntax. So this one element is 4. Okay, so now when let's start with the next for loop. When j equal to 0, I want to check if xi or x0 in our case. So x0 equal to 4 and ARij AR0 and 0 because j is 0 equal to also 4. So that's the condition. True or false? The condition actually it's false because 4 it's not equal, it's not bigger than false. Yeah, and when g equal to 1, x0 equal to 4. Actually, inside this for loop, I'll get only x0. Why? Because this element here or index here, it's 0. It depends on this index. So it's just going to be x0. If I find a bigger number, I'm going to change it. Okay, so let's move. When I are 0 and 1. Okay, there's something that's totally wrong. Yeah, AR 0 and 1. So here, this subarray is AR0 and 1 is 5, which is 5. So the condition in this case is true. What's going to happen now? X0 is going to equal to 5. And when j equal to 2, x0 equal to 5, because you have already changed it from the loop before. And now AR0, 1, sorry, 2 equal to 1000. The condition is true. In this case, what's going to happen? I want to do something here that's really annoying. Exactly, yeah. So now x0 is equal to 1000. And so until we finish the whole loop, I want to start now when I equal to 2. Now AR 2, I mean 1. Yeah, sorry, that's my fault. So delete so AR 1 is the next subarray, which is this array here. So it's going to be 13, 27, 18, 26. And X, yeah, okay. So X is now X equal to 0, what was it? For 1000 we generated from the previous loops, and now we pushed another element, which is the first element in this array. So now X equal like this. Now it has two elements, 1013. Okay, now what's wrong? Come on, yeah. Here we are going to start all over again when j equal to 0. Now x1, not x0, because like I said before, it depends on this index, not on the j. So x1 equal to 13, because x0 is 1000, and okay, that's the largest number in the previous subarray, and we want to keep it. So now x1 equal to 13, AR1, 0, which is the first element in the next subarray, which is 13, it's false. The condition is false. There will be no changes when j equal to 1. x1 it's still 13, no changes. AR1, 1 equal to the next element, which is 27. So the condition is true. What's going to happen now? x1 is going to equal to 27. And we will do it a couple of times until we get the whole largest numbers, and we get this result over here.